Hi students, in this video we are going to discuss some numericals. Numerical number 1. Write the dimension. Write the dimension of A and B, A and B in the relation P is equal B minus x square whole by 80, where P is power x is distance, and t is time, Once again I am repeating the question, my dear students. Write the dimensions of A and B in the relation P is equal B minus x square by 80, where P is power, x is distance and t is time. This is the question. Now go for solution. The given relation is The given relation is P is equal B minus x square by 80. Consider this is equation number 1. Now since x square is subtracted from B, therefore the dimensions of B, are of x square. The dimensions of B are of x square. That is, the meaning is, B is equal to L square. That is called x square. Because x is a displacement, as a result L into L square, therefore L square is equal to nothing but B. Because same dimension formula only will subtract from the same dimension formula. That is the reason. Now equation consider this is equation number 2. Now equation 1 can be written as P is equal L square. P is equal to L square. First I am repeating this point. The dimensions of B are of x square. X is a displacement. That means only one dimension will be, same dimension will be subtracted from the same dimension. Therefore, B is equal to x square. X is equal to displacement, that is L square. Consider equation number 2. Now equation 1 can be written as, now equation 1 can be written as P is equal to L square whole by A T square. Therefore, A is equal to, how we can write it as L square, A is equal to L square by P T square. Okay, and therefore A is equal to L square whole by, what is P? M L square T to the power of minus 3 into, what is it? What is T? This is T, PT. This is also, sorry, T only. T. What is T? Only T. Therefore, A is equal, take this one upward direction, m to the power of minus 1, L square cancel. Now, T to the power of minus 3 and T gives T to the power of minus 2. Once you can come up, becomes as T square. Therefore, the dimension of A is equal to m to the power of minus 1 L0 T square. Now, so now tell me what we derive here. Here the B is equal L square. Okay, and also A is equal m to the power of minus 1 L0 T square. These two we have to solve, and we already solved. So like that we have to solve the numerical. Now we are going to discuss another numerical. Please observe carefully. Now numerical number 2. Numerical number 2. In the equation in the equation y is equal a into sine of omega t minus kx, omega t minus kx. Obtain the dimensional formula Obtain the dimensional formula of omega and k, omega and k, given x is distance t is time. Once again I am repeating the point, my dear students. In the given equation, y is equal to a sin of omega t minus kx. Obtain the dimensions formula of omega and k, given x is distance, t is time, omega is angular frequency, k is spring constant. Now go for the solution. Go for the solution. Given equation, is y is equal a means amplitude, a sin of omega t minus kx. Okay, now therefore the argument of a trigonometric trigonometrical functions that is angle is dimensionless. Once again I am repeating the point. The argument of the trigonometric function is that is angle is dimensionless. That means, what is the meaning for that one? That is omega t is equal theta. Omega t is equal theta. Theta means how we have tried. See, observe carefully, like this, called theta. Okay, now therefore we may write omega is equal theta by t, that is equal 1 by capital T. Therefore omega, the dimension formula is m0 L0 t to the power of minus 1. So now tell me, what is the omega? m0 L0 t to the power of minus 1. Now kx is equal also theta. How we can write theta? Please observe carefully, like this, theta. Okay, this is very important. Therefore kx is equal theta, where k is equal theta by x, that is equal 1 by L, that is equal L to the power of minus 1. Therefore, K is equal to M0 L to the power of minus 1 T to the power of 0. That means what the examiner want? The examiner want omega. What is omega? We already derived M0 L0 T to the power of minus 1, and also the examiner want K. What is K? M0 L to the power of minus 1 T to the power of 0. So that we already derived omega and K. What are the dimensions of for that one? Okay. Now we are going to discuss numerical number 3. Now we are going to discuss numerical number 3. Justify L plus L is equal to L and L minus L is equal to L. This is the question. Once again, justify L plus L is equal to L and L minus L is equal to L. Now solutions. Now solution. When distance is added, when distance is added to distance, when distance is added to distance, we get distance only. We get distance only. Once again I am repeating the point. When distance is added to distance, we get distance only. So this is justify. This justifies L plus L is equal to L. Now second point, when distance is subtracted from distance, when distance is subtracted from distance, we get distance only. We get distance only. Therefore, this justifies L minus L is equal to L. Okay, that means from these two, which principle is involved? Principle of homogeneity. Principle of homogeneity. Okay, now what is principle of homogeneity? Whenever the same dimension subtracted from the same dimension, we will get same dimension. Whenever a same dimension added to a same dimension, we will get the same dimension, called principle of homogeneity. So that we justify L plus L is equal to L, L minus L is equal to L. Both are right according to principle of homogeneity. I hope you understood this video. Thank you very much for watching this video. Thank you.